So my name is Yason, and I want to talk about how we're going to allow billions of people to build billions of solutions using a concept I call documentation as code. First, we're going to watch an educational video.
Yes, what is it? What is it?
Can I play with it?
No, you can't play with it. You will enjoy it on as many levels as I do. The colors, children.
So just like in this video, a lot of presentations about Agentic AI look great in the presentation, but then when you go out and try to do it on your own, you're struggling. You're just not enjoying it on as many levels as the presenter was. So we're going to, in this presentation, I'm going to focus a lot more on limitations, or I'll try, and hopefully avoid this highlight reel effect that happens often. So first I'm going to see this idea. What I mean by documentation as code is any solution where instructions written using natural language are executed by an agent. So you can think of it as in you're writing your Python instructions, you have a Python interpreter translating those instructions into machine code. In this case, the agent is doing that job, and your instructions are written using your native language. But let's discuss a little bit about what are agents. Dictionary definition is that an agent is a person who acts on behalf of another person, and Agentic AI is a software program that is driven by an LLM and uses tools to do things for you. And tools are just pieces of code that it knows about. And when you try to do something with agents, the learning curve is high, the LLMs produce excessive output that is hard to modify, and when they're wrong, it's unforgivable. So a lot of this presentation is actually provoking you to think differently about the place of agents in our world. So what if we're not looking for an answer? And I can talk about this for about 10 minutes, but I won't. What if it's okay to make mistakes? I know a therapist who can talk about this for hours, and maybe agents are not supposed to solve every problem. Another way to think about agents is in context of evolution of code. We started out with the tubes, punch cards, assembly tapes. Then we got higher level languages like C, even higher Python, and frameworks, meta frameworks, no code where the GUI builds things for you, and millions of people were able to build millions of solutions with no code. Now with the advent of useful LLMs, we come to documentation as code, where you just write requirements and execute. And just as a reminder, this little dinosaur to the right shows us that the evolution of new forms does not necessitate extinction of earlier forms. So birds are dinosaurs, if you didn't know. But yeah, basically with the documentation as code, it's a higher level of language still. And with it, billions of people will be able to build billions of solutions. One of the limitations that is going to be hard to overcome is, it's going to be slower than a fine-tuned algorithm. But if we get a little philosophical here and say the solution is a function of the problem, and we try to find what can we actually do with this. So one category of problems that is kind of easy to solve with this is anything where time to build is high, but immediate benefit is low or uncertain. So it's like a proof of concept that you work on for 2 months, but nobody's going to use it, nobody likes it. It happens all the time. Personal projects with a limited audience. Internal tooling, because ain't nobody got time for that. And another category that I'm proposing here is unique personalized experiences, where you'll wait extra 10 seconds if the information presented to you is unique to you. You're not going to find this anywhere. So that's what we're going to focus more in this presentation. Through a demo, kind of a journey here. We're going to take a journey to the demo. But basically, we're going to build a dashboard for our GitHub repo, because our manager keeps coming to us and saying, hey, you're a superstar, you can do this in 30 minutes, can you get me some statistics about our GitHub repo? And the requirements keep changing. So we're going to start out with a traditional solution and then transform to a disk solution. All right, so initial requirements for the most prolific author of GitHub issues, give me the number of issues they have created. given the author's issues, I want to know the number of comments that the same author has made. So it looks like we're looking for a level of engagement by our most prolific author. We're going to throw together a quick front end with a table and some data coming from our data endpoint. Can anyone see this? And it's going to look like that. Very simple. So the backend, I'm going to skip a lot of backend code and just focus on the different algorithms required to produce this. And it's loops, more loops, loops, and a data structure that helps us, provide some structure that the front end can actually parse and display to the user.
I feel like there should be a programming textbook. It's just called loops, 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 and then
All right, so that's the result we get. Pretty underwhelming, but those were the requirements. So to accommodate some of these changing requirements, we decided that we want to use what's called a React agent, which is a reason, act, observe, iterate loop that was introduced about 3 years ago by this white paper, and it's made more accessible by tool calling support from LLM providers. And we're going to use a pre-built LangGraph React agent that looks like this, where at the start you send a request to the agent reasons about your request. If it decides that it needs to use a tool, it will call the tool provides some response, the agent reasons again, and keeps going in this loop until it can satisfy the request, and it ends the cycle. So let's see what our implementation is going to look like. We're going to have our data structure, which is just going to contain our fields that we want, and we're going to have our data endpoint, and in the data endpoint we're going to put our requirements. So those are the requirements that I read out earlier for those who are not able to see. And then we're going to call our AI agent helper function. So to get that agent going, we have an LLM, we get some tools for GitHub, and we create the React agent from LangGraph. This React agent is for demonstration purposes only. If you were going to do this in production, you probably want to create your own React agent, just to avoid a bunch of limitations. Or maybe it's good enough. So we're going to pass in our LLM tools and our format that we expect from the agent to the constructor, and then everything else is just boilerplate for producing structured output from the agent. So we got our React agent, and the result is the same but slower. So it's a little bit underwhelming, but let's see how, well, let's look again at the code. We quickly recognized that if the requirements were to change, let's say we wanted to see the comments themselves, not just the count, we would have to change this data structure. Changing the data structure would require us to change the front end. Potentially some, the prompt also is bound to that a little bit. But we kind of recognize that this is not a perfect solution. All right, so new requirements come in, and we want to actually see the comments and the issues, the text itself, not just the statistics. So now we're again on the hook to write some code. So we're going to go and make this agent a disk agent now. We're going to make sure that the user, our manager, who's just not helping with our promotion, we're doing this low visibility, low impact thing all the time, and it's ruining our promotion plan. But so we're going to do disk here, and to do that, we decide that we're going to have to get rid of that coupling with the back end and the front end by telling the agent that it's actually going to generate HTML. So now the responsibility for the front end and the back end is on our agent. We don't have to worry about that coupling anymore. It's handled by implicit algorithm that's provided by the LLM. And everything else is basically the same, minus the structured output boilerplate is replaced by unstructured output boilerplate. All right, so now our endpoint has no code, basically. It's just calling our AI helper, and all the code, all the instructions are basically in our text file that the manager now can modify. So I threw in a little styling here. It says using Bootstrap CSS, and we get a result, just something that looks a little better, right? We got our comments, we got our issues, and it's actually filtered a bunch of comments from other people, right? But I hope at this point everybody here is thinking, enough with these contrived examples. So lame. So we're gonna still go with this a little bit and see what can we do with just modifying a little bit of the requirements. And we're gonna add new requirements that we're gonna need a link for our GitHub and use accordion style to make it easier to navigate. So we're gonna still do the contrived example. I jumped it a little earlier than I was supposed to say it. But all right, so I got our requirements here. I don't know if anyone can see this, but it's basically all the same stuff we talked about before. It's just in one file, and we've got our server code. It's all the same stuff. Plus, you get to see the MCP stuff, and we're going to start the server. The server is up and running. We're just going to run it. Okay. We got pre-built stuff in case this doesn't work, so you get to see it. So let's jump back to what's happening on the agent. The agent receives our prompt, which is from our file, and it decides that it needs to get GitHub issues. And that's a tool that it has in its toolbox. The tool returns this output from GitHub, and then the agent decides that, oh, I don't have the actual comments text. And it goes and queries all the comments all asynchronously, so this is actually pretty fast. Provides us with the comments, and then we get the HTML. So let's see what we got here. So we got, now we can navigate this a little better, and with just adding 2 sentences, you know, our interface is a lot better. And we got a link, we can go and check, you know, whatever we want. Here. So now, we're gonna stop with the contrived example, and we're gonna do something a little bit more interesting. So the more interesting thing here is we're gonna organize a hackathon. We're gonna jump there. Fill the kernel so I don't run into this. So we're gonna organize a hackathon. This actually something I've done, or not organized, participated in a hackathon, but usually they'll have a GitHub repo that has the issues I used for submitting your hack, where you put all the text and links and all that stuff. So I'm telling the my agent that I'm organizing a hackathon. People are submitting their hacks to GitHub repo using GitHub issues. And I'm also going to introduce some reviewers. We're going to use them later. This is me, Scarlett J, and Sydney S. And we're going to take the top 10 issues, and we're going to, what we want to see for each one is the current assignee. And you can see this, I ran into an issue with GitHub providing an assignee field and an assignees field. And the one that actually has the correct data is assignees. That took a little while to debug, but the other one is labels. We just want to see these. These are provided by GitHub. But the last 3 is project repo, demo video link, and deployed application URL are all extracted from the text of the issue. So this is where the LLM comes in and is able to parse this stuff. And then we have then we have the drop down to assign people to review. We describe the button. We tell it what the button is supposed to do, and we're going to style it and so forth. I'm going to actually run this right now because this takes about 30 seconds or more to run. And then I'm going to go into and show you a little bit of what changed as far as the code. So now we have this running. We're going to go here. We're going to run it. So again, it started running with the prompt, but we're going to go and see what I did to the. There it is. So we have the same agent that we had before for generating HTML. Put the text there into this file, and it has that HTML, the 3 lines that tells it that you're an HTML server, and then the rest of the stuff is describing an ACT endpoint, which actually is served by another agent. It's another unstructured agent, and we're just kind of telling it that you need to write some JavaScript to tell this ACT agent what to do and the data to do it with. So let's see what the code turned into more. So the ACT agent is the same as the other agent. I'm just using a mini because it's not supposed to produce any output or no reasonable output. And it just, I'm telling it to not do a bunch of things that the LLMs want to do by default and just produce minimal output. It's just supposed to do what it's told. Nothing special.
He's marked out. So.
Yeah.
Right.
Yes, because this is processed by, it's actually turned into code. So that's the, let's see what we got here. So now we got our unique perspective. That's the unique experience we were seeking, where GitHub doesn't have all the fields that we want, doesn't have all the parameterization that we want to make it to achieve the level of personalization that we want. So we got these things here, and they're extracted from the text. I created, these are basically on-the-fly parameters, and let's try our act agent. So I'm gonna assign me to this one, and it goes out to the act agent. Act agent will succeed or fail. If it fails, hopefully okay, so now we got it assigned. And we can go and check what's happening here. Assigned just now, assigned to this issue. So the thing is, with this act agent, I don't think it's production ready. I haven't gotten it to being production ready. Out of a couple hundred times I've run it, one time it actually destroyed the data. But 99.5% of the time it actually does the job, which is actually surprising given how little time I invested into it.
The definition of does the job is do not destroy the data.
Yeah, it actually does the job. Maybe twice it errored out because the JavaScript was broken. I had to regenerate the JavaScript from scratch. But that's the kind of experiences I was talking about. Unique, where nobody else has this because I just generated it. All right, let's look into the presentation again. So. Okay, limitations. So one of the limitations, the tools still need to be coded. If you change the requirement that your MCP server or your tools are not supporting this requirement, you'll need to write some code. You must learn agent specializations and limitations, just like I did with that assignee and assignees. You kind of need to find where it's good, what it's good at, and what it's bad at. Runtime performance is slow. You get inconsistent outputs. Sometimes it blasts out too much data, and you have to kind of limit it. Incremental refinement is challenging, and engineering rigor is not at all part of this presentation, and it's not free. So next steps is the stuff I'm working on to kind of alleviate some of these limitations at Breva Apps is the dynamic tools where you simply drop in documentation or your MCP server, and now you've got new capabilities. Stateful agents where checkpointing and persistence caching allow you for faster reloads and reuse of the data, so you can do iterative development. And you get the output consistency where it's consistent enough for your use cases. And human in the loop is unavoidable because the human is providing the requirements and verifying the output. I challenge you to find a human that will take a process that's 100 steps long and with just a couple sentences achieves what you wanted. You will fail 100% of the time. So also human in the loop will assist debugging. All right, so let's look more closely. What have we achieved with about 90 lines of code? We have literally a general purpose website building disk agent. And it's more than just a window GitHub. By giving it more tools like website extraction, search capabilities, or Jira. If you give it a Jira MCP, now you can do Jira dashboards all day long and faster. So agent actually becomes your kind of window to the internet where you don't have to be seeing that pop-up ad that is showing up because 1 out of 20,000 people is going to click it. Your agent can filter your experience. The attention harvesting platforms, again, filtered and removed by your agent. And you take control over the algorithm a lot more. You're getting the experience that you want, not the experience that the algorithm wants to give you. So, that's kind of, I think, a revolutionary approach to viewing what's on the internet. And this is just one type of disk agent. This is just an example of what you can do once you start thinking in terms of language instructions being the same as code instructions. And you get to discover families of problems rarely solved before, like developer setup instructions. That was supposed to be humorous, but yes, maybe it's too close to home for a lot of folks here. A small website for your party that's, maybe 20 people are going to visit. Tennis league at work that's going to fall apart when you find a new job. Behavior tracking app for your child that the teachers are just not going to use, and billions more personalized solutions to highly personalized problems. That's it.